All right, so objective, find the product of two matrices, okay? And find the product of two matrices is not hard. It's a little tedious, but it's not hard, okay? So bear with me, okay? So by definition, product over a row vector and a column vector means that you are multiplying a matrix with the same number of rows to a matrix with a number of rows to the same number of columns in the other matrix, okay? That means that they have to match up. So the number of rows in the first matrix has to be the number of columns in the second matrix, okay? And that's what I told you about the smile test. Okay, so in the smile test, so for example here, let's say I have a 3 by 1 matrix here, times a, I meant 1 by 3, I wrote that backwards. Low C and oh, I could have just made it up, right? I'm making it up anyway. How could I be wrong on something I'm making up? If I have a 3 by 1, it only can be multiplied by a 1 by something. So 1 by 6. But as long as the number of these guys match up, the number of columns and the number of rows match up, pew, 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 smile at you. It works. Does that make sense? That's what the smile test is. So if the number of columns in the first one matches the number of rows in the second one, then you're good to go. And that's because you're kind of, in essence, distributing, but you're multiplying the first element in the row times the first element in the column, plus the second element in the row times the second element in the column. And you just keep going. Yeah. It's just multiplication and addition. Okay. All right. So let's do a simple one, right? So we're going to check to make sure that they work. So notice this is a 1 row, 5 columns, right? 1 by 5. And this is 5 columns, 5 rows, 1 column. Do they work? Yeah, smiling at you. So that's good to go, correct? So I'm going to multiply the first element in the row to the first element in the column. So we have -2 times 3 plus 3 times 0 plus 5 times -2. There's only 4, by the way, guys. I just realized I can't count. I was up to 3 a.m. grading late work. And then I have -1 times 4. And we're going to pretend that we never saw these 5s and that they're 4. Okay, the numbers at the end tells us how big of a matrix our product will be. Our matrix is going to produce a 1 by 1. So this is going to be our product matrix. Is going to be a 1 by 1. That means 1 row, 1 column. And so notice here, that's what it's going to end up being. So we have -6 plus 3 minus 10 minus 4. That gives me -3 minus 14. Oh, I saw, guys, I'm tripping. You saw nothing at all. Wake up, Jones. Wake up. -6 minus 10 minus 4. Let's try that again. -16 minus 4 is -20. And that's our matrix. And we said we needed a 1 by 1. Is this a 1 by 1? 1 row, 1 column. So it's tedious, but is it difficult? It's just multiplication and addition. Okay. So do you understand a single one? Because now we're going to do larger ones. Yeah. All right. So we're going to set up the matrix. So it says a clothing store sells men's shirts for $45, silk ties for $18, and wool suits for $425. Last month, the store had sales consisting of 115 shirts, 215 ties, and 32 suits. What was the total revenue due to these sales? Okay. When it wants you to create a matrix, you're thinking about what categories you have, right? So my categories here are types of clothing, right? So my first one, I have the price of the clothing, $45, $18, and $425. That makes up my first matrix. In order for this to be multiplied by something, the next matrix has to be a 3 by something. Does that make sense? It could be a 3 by anything, but it has to be a 3 by something because how many elements are in my first matrix? 3, and it's a 1 by 3. So then this one is how many I sold. So for shirts, I sold 115. For ties, I sold 215. And for suits, I sold 32. And that would be the matrix that you're setting up. And when you're setting up the problem like this, it's basically what you would do anyway, right? Would you not multiply 45 times 115 to find out? So you would multiply 45 times 115 plus 18 times 215, and you get a 1 by 1 product. Plus 425 times 32. So what was their revenue? That's a big one. Put that in the handy dandy calculator. So we have 45 times 115 plus 18 times 215 plus 425 times 32. Is this not what you would have done even if you didn't create a matrix to find what they made? So you end up with 69,335 was the total revenue. So could this be solved without you setting up a matrix? Yes, but if the problem asks for the matrix, it's getting a matrix. All right, so matrix multiplication. Again, summarizing, the number of columns in the first matrix has to be the number of rows in the second matrix. Capiche? All right, so remember we wanted to smile at us. So if we have an m by n, it has to be times an n by whatever, because these have to smile at us, and our product will be the size of the number of rows from the first one and the number of columns from the second one. If your product does not come up to this, then you did something wrong. All right, let's get bigger. Let's check if we can even do this. Can we do A times B? What are the dimensions of the first one? 3 by 2. And what are the dimensions of the second one? 2 by 4. Does it smile at me? Yes, and it's going to produce a 3 by 4 product. Okay, and now we're going to begin multiplying. Are we good? Okay, so we know that we're creating a matrix that has 3 rows and 4 columns. Does that make sense? So we're going to have 3 rows and 4 columns. So the first one, you're going to do the first row times the first column, first row times the second column, first row times third column, first row times the fourth column, and that's your first row in your matrix. So we have 3 times 3 is 3 times 3 is 9 plus -1 times -1, which is 1. Yeah. Okay, that's our first element. Still good? Okay, we're going to do now this with the next row, the next column, I'm sorry. So we have 3 times 2, which is 6. We have -1 times 0, which is 0. Second column is done. Now we're going to do the third column. We have 3 times -3, -9. We have -1 times 2, -2. Then we have our last one. We have 3 times -4, -1 times 1, -1. And that's our first row is done. And then we're going to repeat it again. for the next one. So now we have 0 times 3, 0. We have 5 times -1. We have 0 times 2. We have 5 times 0. We have 0 times -3. We have 5 times 2. We have 0 times -4. 0 times -4 is 0.
Oh, I'm sorry, I was in the 5. Wow.
I was like, wait.
I had to correct that, sorry.
Oh, it happens all the time. I'm your teacher. You've seen it. 5 times 1, 5. Okay. So when I was a student, I did the line test because it helped me make sure that I had touched everyone. Do you have to do the line test? No, it's just, it helps though, because I know that if I'm going to have four columns, notice how I'm touching everyone as I'm doing it. -2 times 3. 1 times -1. -2 times 2. 1 times 0. -2 times -3. 1 times 2. -2 times 4, -4. And then 1 times 1. Did I produce a 3 by 4? We all see the 3 rows and 4 columns? So I did that. So my answer is, what is my product? 9 plus 1 is 10. 6 plus 0 is 6. -9 minus 2 is -11. -12 minus 1 is 0 minus 5 is 0 plus 0. 0 plus 10. 0 plus 5. -6 and -1. -4 and 0. 6 and 2. 8 and 1. And then that is our product. Tedious, but doable. What are your questions? This one right here. It's -2 times -4. Other questions? We see the pattern? All right. Can we do A times B? Well, what are our dimensions of A? Row column. 2 by 3. And what are the dimensions of B? 3 by 2. So can we multiply them together? Yes. Now, if I did B times A, does that work as well? So that means I would have a 2 by 3 times a, I didn't switch them. No. I would have a 3 by 2 times a 2 by 3. Can I do it here? Yes, so they're both doable, right? Since they're both doable, I would like for y'all to do them. So you need to practice the skill. So I'm going to pause and let you practice the multiplication. So you're going to do A times B, then you're going to do B times A, and we will check your results, geniuses. All right? So it gives you 9. So your first element is 9. Then we have 4 plus 0 minus 3 equals 1. So we have 9, 1, and then we have 2 plus 6 minus 3 equals 5. And then we have 1 plus 0 plus 9 equals 10. So those are your elements. So you have a 9, 1, 5, 10. Okay, good. So the second one, you should end up with a 3 by 3. Can I do what? So on the second one, it's 2 times 4 plus 3. Wait, did I go the wrong way? I went the wrong way. Haha, I lied. Ignore that. That's not what I meant. 10 plus 1 times 1. That's your first element.
Yeah, I'm lost after this second.
It's better if you switch it around, but I'm too lazy to switch
Yes, I
it.
know, that's what's confusing me.
4, 0, -1, 1, 2, 3. There we go. So we did 2 times, we did this row, this column. Now we're gonna do this row, this column. Then we're gonna do this row, and this column. Huh? What do you mean you're confused?
Wait, so.
No, I need you to try and write it out.
So
I need you to try.
the part that confuses me is, so whenever I multiply 2 and 1, right, it's like, you'll go 2 times 4 and then 2 times 1.
It's row, like that completed row. Like until you complete that row times that other column, you're not moving away from that element. So I'm multiplying all of this to this. So that gives me 2 times 4 plus 1 times 1. That's one element. Then I'm going to do all of this times all of that. That gives me 2 times 0 plus 1 times 2. Can't see that. I see that now. I circled this, circled that, and wrote 2,
I don't know why it's
0.
confusing me so much.
I don't know if the circles.
No, it's just like, oh, okay. I've got like a mental block.
So it's the top line by everything.
It's the row times every element in the column.
I did the first top row and easily, I just don't.
And so on.
So we have, then the last one I read out of room, so I'm gonna slide it in there too, -1 plus 1, 3. And then you're gonna repeat again. So we go back to red. I have 3, 0, and 4, 1. So that's gonna give me 3 times 4 plus 0 times 1. And then I have 3, 0, and 0, 2. That gives me 3 times 0 plus 0 times 2. And then I have 3, 0, and 1, -3. So that gives me 3 times -1 plus 0 times 3. Helping, not helping? Yeah? Okay. Sorry that this is written really weird. It's sideways and sloppy. Are there any questions? Do we see how I got the numbers? Do we not see how I got the numbers? 9, 2, 1, 12, 0, -3, -1, 6, 10. Yay, nay. Yeah,
Yay.
got it?
Yo.
All right.